All right, welcome back to Mr. P Helps with Calculus. This is Unit 0, day number 9, and we're going to be solving equations with exponents, or in exponential format. So in this case, we're going to do square root of both sides, and the square roots and squareds cancel each other out. You're left with simply x plus 4. Square root of 25 is both positive and negative 5. So then what you would need to do is solve this twice. Solve it for 5, solve it for negative 5, and you're most likely going to get two different answers. When you subtract 4 from both sides, you get 1. And over here, when you subtract 4 from both sides, you get negative 9 are your two solutions. Because it is quadratic, remember quadratics can have two solutions when they have two x-intercepts. Over here, so one way of doing this question would be to change this to a radical format. So that would be x to the 2/3. Now keep in mind that whenever you have a fraction as your exponent, the numerator becomes the power of that base, and the denominator is the index of its radical. So that's the third root. Now, the reason why I did that is because I can now do it in two steps. I can raise each side to the power of 3. These cancel. I'm left with x squared equals 64. 4 times 4 times 4. And then I can do square root of both sides and see that the answer is both positive and negative 8. Now, solving these, fairly easy in the first one because we have the same base for both. Now, if I were to simplify this and say 5 to the x is equal to 5 to the 7th, I think it would be pretty obvious that x has to be 7. Because that's the only way these two sides are going to be exactly the same. Because if the bases are the same, then literally the exponents must also be the same. Now, using that logic, same thing here, the exponents must also be equal to each other. And then it's just simply a matter of solving using your Algebra 1 skills. We have 3 equals x, and that's our solution. All right, for this one, we can make the bases the same because 1 is really 4 to the 0th power. Now they have the same base. Anything to the 0th power is 1. Bases cancel. And then you can set the powers equal to each other and solve. Divide both sides by 2, and there's your answer, negative 3/2. All right, so for this question, we just need to change them to the same base. 243, 3 times 3 is 9, 27, 81, 243. So that's 3 to the 5th power. Once the bases are the same, exponents must also be equal to each other. So that's negative 2x minus 1 on both sides is 4. And then it looks like our answer is negative 2. All right, so this time I can take 625, change it to 525, 125, 625. So that's 5 to the 4th power. Bases are the same. 2x minus 6 equals 4. 2x equals 10. And then x must be 5. All right, now this question's a little bit different because I can't change 32 to base 4. But what I can do is I can change both of these to base 2. 4 is really 2 squared. Now that 2 squared is raised to the x plus 2 power. And 32 is 2 to the 2, 4, 8, 16, 32. 2 to the 5th power. All right, so now we have 4 that changed to 2 to the 2nd. That's why I put it in parentheses because it's really the same as 4. But that's a power raised to another power, which means you have to multiply the powers. And when you have a monomial times a binomial, you have to distribute that. So this is really 2 to the 2x plus 4 power. And now the bases are the same. So now it's just simply an Algebra 1 equation. And we can solve and we get, it looks like the answer is going to be 1/2. All right, for the next one, once again, I don't think I can make 243 base 9, but I can make them both base 3. 3 squared is 9 to the x minus 1. 3, 9, 27, 81, 243. So 5th power, both base 3. So this is 2x minus 2, and this is 5, because the bases basically canceled out. Then you get 2x equals 7 when you add 2, and then divide both sides by 2, and it looks like your answer is 3½ All right, same goes for when you have fractions. Now, just remember negative exponent rule. 1/2 is really 2 to the negative first power because it's flipped. And then pretty much everything else is done just the same. 16, 2, 4, 8, 16. So that's 2 to the 4th. So we have the 2's have canceled. We're left with negative 2x equals 4, which means x must be negative 2. All right, so one more example, and that'll be it for this one. So 1/49 is 7 to the negative second, because 7 to the second power is 49, and it's negative because it's been flipped. 343 is 7 to the, let's see, 7 times 49 is, so 7, 49, and I believe that is 243. So there we go. So it's 7 to the third. The 7 bases cancel. We're left with negative 2x minus 2. Remember, you have to distribute. Then we get negative 2x equals, add 2, you get 5. Divide by negative 2, and there's your answer, negative 5/2. All right, thanks again for watching, and look forward to the next video. Have a wonderful day.